In our Rube Goldberg project, I'll drop the ball through this tube. Gravity will pull it down. The ball will come out in the end, hit the domino effect, all the way over to this blue poo ball right here, which will hit it down into the socket, pulling on this string, which is attached to this train. The string will then launch it down this ramp, which will hit this ball, which will cause the ball to go down onto the bottom of this ramp and hit the car, releasing it from this, and it'll go down the ramp.
Yeah, so the car will go down the ramp, it'll come over and it'll hit the pool stick right there. When it hits the pool stick will knock that ball over, and the ball will knock these books over in a domino effect. This last book will hit this weight. The weight will fall off onto the board, propelling that ball upwards, which Shaun will catch.
That's our final goal, to catch the ball.
Okay, so to apply Newton's 3 laws, so for the first law, an object at rest will tend to stay at rest, and an object in motion will tend to stay in motion unless acted on by another object. So this ball right here, it's at rest, and then it'll be put into motion without, moving itself, because these dominoes right here will knock that. And for the Newton's second law, force equals mass times acceleration, the force of this ball is equal to its mass times the acceleration it'll get when falling. And for Newton's third law, it's also a conservation of momentum. So the ball right here, when it hits that, an equal and opposite reaction to this ball's action will knock this over. So the action of this train is a reaction, and it's equal action to that ball.
Okay, and so for the conservation of energy, the energy is conserved throughout, as like we see it will go from gravitational potential energy, as when it's at the top of this tube just before I release it. It'll have the gravitational potential energy, and that will turn into kinetic energy. Slowly the margin will get bigger and bigger. Like, kinetic energy will grow as potential energy will decrease, and the net energy is zero. That's why the energy is conserved. And so basically the same idea over here with this weight. It's not in motion, the book knocks it over, gravitational potential energy, and will transfer into kinetic energy, which will then force this to move up.
All right, let's do this project.
Let's go.